Value equations, we treat these very similar to all the other equations, but of course there is one unique detail. Absolute value means everything inside of the absolute value bars is going to be turned to positive. But it's really tough to figure that out right off the top of our head. So we're going to treat these just like equations. With absolute value equations, we're going to rewrite them, and we get to say x plus 5 equals 7, but we also need to account for what is another way that we can get this to be the same answer inside and then turn it positive. So the way we do that is we say x plus 5 equals negative 7. So absolute value equations means we write the same equation twice, but the answer is negative for the second one, and then we solve. So we solve by subtracting 5 from both sides, and we see that x is equal to a positive 2 for one of the choices, and then we'll do the same thing here. And we see that x is equal to a negative 12 for another choice. How can x be two different values? If you think about that, 2 plus 5 is 7, and the absolute value of 7 is 7. Negative 12 plus 5 is negative 7. But the absolute value of negative 7 is positive 7. So we can get two different answers. When we're asked to graph these, if I just take you on a quick journey over here, and I have my number line, I'm just going to do a crude number line, so nothing super detailed, definitely not to scale, so forgive me. But just to graph it, I'm going to come here at a 2, and I'm going to bubble in the 2. And then the negative 12 will probably be right about here, and I would bubble that in. So I then just simply show the dots. I don't link them together. I don't draw any lines. I just represent the dots on a number line. And that's as hard as the graphing gets for absolute value. This one here is a little different. There is a part of the operation, a part of the equation that is not bound by the absolute value bars. We can go ahead and treat that normally in the sense of just subtracting it. I like to say it's not trapped right now. It's not trapped in the absolute value bars. So this just moved over to join its like term, and then I'll go ahead and rewrite these now. So of course this is 6. So we'll have an x plus 1 is equal to a positive 6, and an x plus 1 is equal to a negative 6. From here I'm just going to solve. Subtract the 1 from both sides, so I have x is equal to 5, and then here same thing, subtract the 1, and x is equal to a negative 7. So again, two unique values that when substituted back in to the absolute value bars will then result in the same answer. So if I were to graph these, again, not being really particular on the placement for distance, but just to give you that idea, I'm just going to put the two dots over their prospective answers and not draw any lines or anything like that. So there's absolute value equations. Hopefully that made things a little more clear.